So welcome back, Team 6C. Today I would like you to meet our friend Jimmy. Thanks to Ben who gave our little friend Jimmy a name. We're going to use Jimmy to help us look at our homework from yesterday. The assignment you guys to work on was from Lesson 3 in Mod 6. Let's move you over here, Jimmy. So I'm going to put the screen up here. You might want to pause your screen just so you can kind of check things if I go too quickly. But your job was to put the tally marks in for these. I went ahead and added all of the numbers up as a review, as you can see, and found out we had a total of 26 right here. That would help me out for some bottom information here. Your assignment then was to make a dot plot. And I counted by 2s. You might have counted by 1s, which would have worked perfectly. I just happened to write too large, but you can still see what stands for 1, what stands for 3, and so forth. Made my dot plot. I did not have room to put my title underneath or on the top, so I put my title over to the side. It says number of hours playing a sport. I then had to find out the center of the data. Well, for me, the easiest thing was for me to go ahead and add up 26. I divided 26 by 2 to find that 13 was cut in half. So when I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's why I have that line right there. And then I started at the higher end and counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I found that I met right here and happened to be right where the 3 was. So that's how I found out my center. Then down here it says how many 6th graders reported that they spend 8 or more hours a week playing a sport. So I looked up here and said, okay, 8 or more. Well, there was a dot here and a dot here, so there were only 2. And then the last question I asked you to look at was the 6th graders wanted to answer the questions, how many hours do 6th graders spend per week playing a sport or playing an outdoor game? Using the frequency table and the dot plot, how would you answer the question? How would you answer the 6th graders question? So when I had to answer it, I just kind of said most 6th graders spend 2 to 4 hours per week playing a sport or playing outdoors. When I looked here, most of my dots were here between 2 and 4. Over here, there weren't as many dots, and over here, there weren't as many dots either. So I just kind of made a summarization of what I saw in my dot plot. Once again, if you need to pause the screen so that you can get these answers taken care of before our little quiz on Friday, you can do that. Otherwise, go ahead and let's bring Jimmy over here. Let's go ahead and flip over to Lesson 4. I'm sorry. Let me turn the page over here. We're going to continue looking at some data that we've asked with a statistical question. We've made some dot plots. We've looked at some frequency tables. Today, we're going to look at something called a histogram, which for most of you, you're going to say, that looks like a bar graph. And it is very similar to a bar graph, but we're going to look and see how it is different. So today we're going to look at this frequency table. The story is the boys and girls basketball teams at Roosevelt Middle School wanted to raise money to help buy new uniforms. They decided to sell hats with the school logo on the front to family members and other interested fans. To obtain the correct hat size, the students had to measure the head circumference. Okay, so our circumference, remember, is the distance around the head. Okay, of the adults who wanted to order a hat. The following data represents the head circumferences in millimeters, not inches, but millimeters. So you see all these big numbers here, 513 all the way down here to 618. What we need to do is we need to look at these hat sizes of our adults and decide how many extra small, small, all the way to extra large hats we need to order. Well, if you notice here, this time for extra small, we're looking at a measurement or circumference of 510, and then it says less than 530. So I'm going to look up here at these numbers, and I'm going to find all of the numbers that are between 510 and less than 530. Well, if I look up here in the top, I notice that I've got up here 513, and I've got 525. 531 is larger, and because it's larger, I can't do that, so I'm going to put 2 tally marks here, and I'm going to write a 2. The next one says I'm going to go from 530 to 550. So I look here, 530 all the way to 500. Oh, that's over. So I'm going to stop right there, which is 1, 2, 3, 4, 5, 6, 7, 8. So we're going to put 8 tally marks. And we're going to write the number 8. Okay, we're going to continue doing that on all the rest of them. Please remember, this says less than 570, less than 590. Go ahead and pause your video, see if you can finish filling in the tally marks and the frequency table, and then we will get back together and you can look to see how you did. Okay, so let's go ahead and check and see how you did. If you notice, I kind of look at my numbers from 550 to 570, and then I kind of put some marks up here to help me count to make sure I was accurate. You should have found that in the medium sizes, we needed 15. In the large, we needed 9, extra large 4, and the extra large 2. So if you need to make any corrections, go ahead and pause your screen so you can make those corrections. Otherwise, you can turn over to the next page. Okay, so let's go ahead and look at the first question we have here. It says if someone has a head circumference of 570, what size hat would they need? So if I look down here in my numbers, I see a 570 there and a 570 here. However, one of them says medium and one says large. Well, I obviously can't buy both hats. I can only buy one. But if I look carefully, the medium says 550 to less than 570. So it has to be less than 570. This is not less than, it's equal to. So it looks like I probably will need a large hat. So we're going to basically copy here on our frequency table the things that we had on the front page so we don't have to flip back and forth. I'm going to go ahead and write the numbers here for you. And then I'm going to have you go ahead and pause your video so that you can go ahead and fill in your tally marks. Okay, so you should have filled in your tally marks. I went ahead and figured out our total here. So I added 2 and 8 and 15 and 9 and 4 and 2, and I got a total of 40. And the reason why I did that is because I figured in order for us to kind of find the middle somewhere, we're going to have to find how much we have in total. If I found out by adding all these that we have a total of 40, if I would take 40 and I would cut it in half, most of you know that that would be 20. So when it says here, what hat size does the data center around? If I want to find the center, I'm going to have to go about 20, find 20 starting at the lowest end and 20 here and find the middle. Well, if I know that 8 plus 2 here is 10, and if I would add another 10 to get 20, I'm going to be somewhere here in this area right here. 4 and 2 is 6, and 6 and 9 is 15 plus. So it looks like this area right here is going to be my middle or center area. So for problem number 3, I said the center is going to be around the medium. My next question says, could I describe a pattern that I observe in my frequency column? Here's my frequency column. My frequency column are the numbers, okay? And if I look at my numbers, I started from 2, 8, 15, 9, then 4, 2. So it looks like I started small, went up to 15, and then I went basically, and I decreased again. So the answer I wrote for number 4 was the number start small, but increase to 15, and then go back down. So if you want to, you can pause your screen once again, so that way you can get this written on your paper before we go on to the next thing. All right, so let's go back here and look at our graph. On the bottom, we're trying to learn a little bit here about what it says about a histogram is. It says here that one student looked at the tally column and said that it looks somewhat like a bar graph turned on its side. So for example, if I would take my book and turn it this way, I kind of look like I've got a bar graph here, okay, going up that direction. And a histogram is going to be very similar to a bar graph. We're going to look at some bar graphs. And we're going to do something where it's going to go like this. This will be our horizontal line, and this is where we'll have our intervals, okay? And then up here we'll have what we call our frequencies, okay? So this will be our intervals, and this will be our frequencies. So if you can take your math book and if you open it up so you have both pages open like this, you'll be able to see this information, and you will then be able to look at it over here on basically what we call our histogram. So if you're listening, I said that our histogram is going to have our frequency here. Well, if you remember, our frequency numbers right here were from 2 up to 15 was our highest. So we have a nice frequency here going from 0 and counted by 2, 4, 6, 8, counting by 2s, which works. And then on the bottom we have something here called, these are our intervals, and we're talking about what we measured our head circumference. You see this little jig-jag thing here, which actually means that we're skipping a lot of numbers, obviously. We're going to end up counting, if you notice, by 20s, but we don't want to start with 20 and count 20, 40, 60, all the way to 510. So this here allows us to skip a lot of numbers, and now we can start with our pattern of counting by 20s. If you notice, our interval here says from 510 to 530. Well, when I looked over here at my frequency table, I found out that 510 to 530 was 2. So you will notice over here, my bar graph here went up to 2. From 530 to 550, let's slide over. 530 to 550 was an 8. So we drew the bar graph up to 8. 550 to 570, let's look here. 550 to 570, we're going to make a bar here up to 15. Well, obviously we're going to come up this way. 15 is going to be halfway between 14 and 16, so I'm going to do that. And I'm going to go ahead and just kind of color it in like so. My next interval is from 570 to 590. 570 to 590 is 9. So I'm going to come up this, find 9 is between 8 and 10, and make my bar. My next one's 590 to 610. 590 to 610 is at a 4. 590 to 610, let's go up to the 4. And my last interval here says 610 to 630. 610 to 630 was a 2. Okay, so when it says here that we are to complete the histogram by drawing the bars, we did that. Okay, so now that we have our histogram filled in, you will notice that a histogram looks very similar to a bar graph. Some of the differences that between a histogram and a bar graph are the fact that the bars, as you can see, are touching each other. There's no space in between them. And then the other thing, the biggest difference is you will notice that a histogram has what we call intervals. There's not a single number right here on the bottom representing this bar. This bar represents anything from 510 up to 530. And so you're going to notice that this is just a little bit different than our bar graph. First question I have down here says, is based on the histogram, describe the center of the head circumferences. So we have to find the center. Now, once again, this is kind of hard to do when you're looking at a histogram. And so I still would probably look at what we would call the total. If we notice we had here was 2, this was 8, this was 15, this here was 9, we have a total of 4. And this was 2. And if I add all of those numbers up, remember I had the answer of 40 earlier. And when I cut that in half, I know that half of 40 is 20. So when I look at about 20, if I start here and I add 2 plus 8 is 10, and then if I add to get to 20, I'm going to probably end up somewhere here in the middle. So I kind of estimated that I think the center is going to be around 560. Okay, I'm not going to have an exact number, but I have an estimation. Okay, the next question says, how would the histogram change if you added head circumferences of 551 and 569? Well, if you notice, 551 would be right in here, and so would 569. It's going to be in here, so I'm basically going to make this bar go up by these 2 scores. So I put here that the bar 550 to 570 would increase up to 17, when it currently is at 15. But if I would add a bar up for these two scores, I'd go up by 2. So I'll move that up so you can write that down. Remember, pause your screen if you need to so that you can stay up with me. Come back over here, Mr. Jimmy. We need you here. And the next question says, because the 40 head circumference values were given, you could have constructed a dot plot to display the head circumference data. What information is lost when a histogram is used to represent a data distribution instead of a dot plot? So basically what that means is when you guys look here at your histogram, you know that there were 2 people who have a size between 5'10" and 5'30". Do you know what their head circumference was by looking at this? Do you know if it was a 5'11", a 5'13", a 5'14"? We don't know. We don't know what the individual scores were. Same as this thing between 5'30" and 5'50". There were 8 people somewhere in between here, but we don't know their exact individual measurements. So I wrote down here for problem number 8, in a dot plot, you can see individual scores or values, whereas obviously in my histogram above, I can't. So I could give you a second to pause and let you write that down. And our final question on this page says, suppose that there had been 200 head circumference measurements. 200. Well, first of all, I can tell you right now, I don't want to sit and make 200 dots for dot plot. But it says here, explain why you might prefer to summarize this data set using a histogram than a dot plot. Well, I just said because there would be too many dots on a dot plot, and it would be hard to read. I'd have a very hard time counting 200 little dots if I made this dot plot like this with all of my dots. So go ahead and write that answer down for me. Pause your screen so you get it done, and then you can turn over to the next page when you're ready. Okay, so let's look at our histograms here that we have. It says, histogram is useful to describe the shape of the data distribution. It is important to think about the shape of a data distribution because depending on the shape, there are different ways to describe important features of the distribution, such as center and variability. A group of students wanted to find out how long a certain brand of AA batteries lasted. The histogram below shows the data distribution for how long in hours that some AA batteries lasted. Looking at the shape of the histogram, notice how the data mounds up around the center. So they put a line here for our center and how it kind of mounds up here and it kind of mounds. Looks like a mountain here. Okay. We would describe the shape as mound-shaped or symmetric. So we're going to write here mound shape or symmetric. If we were to draw a line as they did down the center, you will notice how each side of the histogram is approximately the same or mirrors. So meaning on this line right here, if I would fold my histogram in half, it would be pretty close to matching up and folding in half. It's not going to be perfect, but it's pretty close. These 2 bars are close to the same. These 2 are close to the same, and these 2. So that's where we call this mound shape or symmetric. Let's look down at our next histogram. This is another group of students wanted to investigate the maximum drop length for roller coasters. The histogram below shows the maximum drop in feet of a selected group of roller coasters. This histogram, sorry Jimmy, was a skewed shape. Most of the data are in the intervals from 50 to 170, but there are 2 values that are unusual over here. Are unusual ones right over here. They're not very typical when compared to the rest of the data. So what I do is I kind of start here at the 0 and I kind of trace up and I kind of go down and try and touch all the bars. Now when I look at this, I think of a slide. Now if I'm going up the slide and I'm going to slide down, which side does it look like I'm going to slide down? Well, to me, this looks like the latter side where I'm going to go up and I'm going to slide down to the right. And because I'm going to slide down to the right, this kind of histogram is called skewed right. So we'll just write that on here so we can remember that. Okay. and then we'll flip over to the next page. Okay, the next histogram that was made for us is about highway mileage. It says the histogram below shows the highway miles per gallon of different compact cars. Describe the shape of the histogram as approximately symmetric, skewed left as if I'm going down the slide to the left, or skewed right as if I'm going down the slide to the right. So let's do this again. Let's start here at 0. And let's trace up here on our bars like this and try and touch all the bars. All right. Symmetric. It doesn't really look like I could find a middle and fold this in half and it's going to meet. Doesn't look like that at all. So I know that it can't be this. Now I have to decide, does it look like I'm going up and down the slide to the right, or I'm going up or down the slide to the left? To me, it looks like this would be my ladder, and I'm going to slide. So Jimmy's going to come here, and he's going to slide down to the right, which means I'm going to write skewed right. All right, so our next question says we need to draw a vertical line on the histogram to show where the typical number of miles. Typical, meaning basically the center. So once again, I find it easier to go ahead and find my total. So here this bar goes up to 3, this goes up to 4, this one went up to 5, 2, 1, and 1. Now if I would add all of these numbers up, and you'll have to check to make sure I'm correct, but I think if I would add all these numbers up, I'm going to get a total of 16. And if I take my 16 and I divide it by 2, that's going to give me 8. 8 will be the halfway point. Well, I kind of look at this like here's a box, 1, 2, 3, 4, 5, 6, 7, 8. And of course, then I'd have here 1, 2, 3, 4, 5, 6, 7, 8. So I kind of have cut it in half. So to me, my middle is going to be somewhere right about here. So I'm going to go ahead and just kind of draw a line right down here. And I'm going to, when it says draw a vertical line, I probably would go ahead and write on here that it's going to be around 36, maybe 35. Okay. All right. Problem C says, what does the shape of the histogram tell you about the miles for compact cars? Okay, so let's look at problem C that says, what does the shape of the histogram tell you about the miles per gallon for compact cars? When I look up here at my histogram, I can see where the bars are the tallest. And so what I kind of looked as I looked at here, I've got a lot of cars right here between the 31 and 40 range right there. That's where most of the cars are. So I just kind of wrote here that most cars get around 31 to 40 miles per gallon. And then we're going to only look at one more problem on the bottom, and we're going to stop for the rest of the day. Tomorrow there will not be another lesson. Tomorrow I'm going to give you a little Google form thing just to see how you've been, or I guess how you're doing, and if you're understanding or not. The last question here I want you to look at is it says, describe the shape of the head circumference histogram that you completed in exercise 5. So I want you to decide after you look at your bar graph or your histogram like up this, I want you to trace it. I want you to decide if you think exercise 5 is symmetric, meaning we could fold it in half and it should meet. If it's skewed left, as if we're going down the slide to the left, or if it's skewed right, as if we're going down to the slide to the right. So go ahead and turn over to exercise 5. Look back. Let's look here at our histogram. Let's start here at the 0 and let's go ahead and go up, go up, go up. So look very carefully at this histogram and the line that we drew. And if I look carefully, it's kind of hard to tell if I'm going to go down the slide this way or if I'm going to go down the slide this way. It looks pretty close to where if I would fold it right there, I might be close but not perfect. So to me, I would say the best description for this histogram would be what we would call symmetric. So let's just write over here the word symmetric. Okay, and we will stop there. So thank you so much for following along today on lesson 4 with Jimmy and myself. I will hope to eventually get to talk and see you guys again later on this week.